be starting with the new chapter. Okay. So after work and energy, we have the new chapter, that's sound. Okay. So today we are starting with the chapter sound. And meanwhile, I'm requesting if anyone is having any of the doubt in any questions from any book. Okay. So we'll first discuss that. So if there is anyone who has any doubt in the work, energy, and power chapter, in the last about 2 to 3 sessions, we have done only question and answers from work and energy. Okay. So is there anyone who is having any problem with any? So what is the sound here? First we define sound. What is sound? It is a form of energy. So what is sound? It is a form of energy. Okay. The sound is a form of energy, and how we come to know about the sound, how we notice that there is an energy, that sound. So sound is a form of energy which causes sensation of hearing. So it causes sensation of hearing in us. That means whatever we are able to hear, that hearing ability, it is brought about by the sound. Okay. So sound is the energy which is responsible for hearing. It is because of the sound energy that we are able to hear the different sounds. I am able to hear to you. We are able to listen to each other. That is just because of the sound energy. Okay. So basically, where it finds its importance, there are a lot of things relating to sound. A lot of things having around the sound. Okay. So sound is we are using sound every day. We are using speakers, we are speaking, or even the sound of any musical instrument. Okay. That is what we want. So what is sound? It is a form of energy, and it's a form of energy. That means if wherever you see transformation of energy, so the transformation of energy over there also we will use sound. Like one form of energy getting converted to the other form. Like when you suppose if you try to hit something, so your mechanical energy, it gets converted into, some part of it gets converted to heat energy, and some part of it gets converted to the sound energy. It produces some sound. So sound is a form of energy. And how is sound produced then? How can we produce sound? We'll try to study some phenomena about sound. So how sound is produced? Yes, anyone, how is sound produced?
Vibrating objects.
By vibrating object. Is there any other way by which we can produce sound? Is there any other way by which we can produce sound? Hmm. Okay. So sound is produced by a vibrating body. If any body vibrates, over there we hear some type of sound. Okay. So I'm just asking you, I don't know whether you have people have performed those activities or not. Okay. So what happens when any body vibrate? So that vibrating body, it produces sound. So where all we see such vibrating objects. And what is a vibration? Right. So Prince, what is a vibration? How can we define a vibration?
Sir, a movement.
Movement. Which type of movement?
Mm,
Which type of movement? Do all the movements, are all the movements called
yes,
vibration?
yes, sir.
No, only to and fro motion is called vibration. To and fro motion, that means some substance, if it is moving between two extreme positions, if it moves between only two extreme positions, so that is a vibration. Okay. Like if you observe the strings of a guitar, in a guitar you have various strings, and if you plug the string from anywhere, from any place, if you plug the string, suppose if I plug the string from here, here, or anywhere, or any of the string is plugged. So if any of the string is plugged at any of the points, it will produce a sound. How it produces sound? Because the string starts vibrating at a higher frequency. Okay. And if that frequency is quite high, then we can observe the sound, we can hear the sound. Okay. So in the string, we observe the vibrations. Also, we observe the vibrations in the case of drums. Okay. So all of us have seen the drums being played. Okay. So the drums, they look something like this. And when the drums are played, this is what somewhat drum look like. So when the drums are played, the membrane of the drum, it vibrates and it produces a sound. Right. Similarly, on tabla also, these are the strings of guitar. Okay. On tabla, on strings of guitar, on drum. So all these things are the ones which are vibrating, right? And hence the sound is produced from all these objects. Got it? So can you give me some other examples where we have some vibrating objects producing sound?
Sir, a bell ringing?
Which one? A bowl ringing?
No, sir,
A
a
bell?
bell.
Which one?
A bell, sir, a school bell.
A school bell. Okay. The school bell ringing, that also produces a sound. And what is the vibrating object over here? Here in the tabla, you have the membrane that is vibrating, right? Here in the drums also, it's the membrane that is vibrating. In the bell, what is the thing that is vibrating and producing the sound?
Sir, when you hit the bell, it causes vibration.
Yeah, the bell itself, the bell is made of a metal, so bell starts vibrating. Okay, so the bell vibrates and produces a sound. Try to produce a sound by holding the bell. Let your two hands hold the bell and then hit it. Does it produce the same sound again? It will not produce. Okay, so such sounds, they are produced by some of the vibrations. Now we will see where so if I am speaking, I'm also producing a sound. So what are the vibrations?
The vocal cords.
Vocal cords. Okay, you have a pair of vocal cords which vibrate according to the air that is being pushed out of the lungs. Okay, so the vocal cords vibrate when we are speaking. So that means we do not have any sound which is produced without vibration. There is no sound which is produced without vibration. All the sounds, they will be produced by a vibrating object. If you hear any sound, that means there is something which is vibrating, right? So vibration is the mode of transfer of sound or producing sound, the way you can produce the sound. Now, we have also used some instruments like flute. Okay. we have used flute, harmonium. So what are the things that vibrate over here? In the flute, what vibrates in the flute? Of course, there must be something which is vibrating, then only the sound is produced.
Like the plastic part of the drum vibrates when you hit it.
Where?
Like the plastic part of the drum, like the white part, when you hit it, it
Yeah, the white
vibrates.
part, that's in the drum. So we have already called, and that we call as the membrane. So in the drum, you have the white part that is called as the membrane, which vibrates. Okay. In the bell, it is the bell itself, the body of the bell that vibrates.
And the
In a,
chords.
when we are speaking, then vocal cords are vibrating. Then what thing is vibrating when a flute is, when you
Air,
are playing a flute?
air,
The air
air
columns.
column.
Air columns. So during flute and harmonium, when flute and harmonium are played, so here we have the vibration of air column. Okay. So air column, that means air is a fluid, it is a matter and it can be made to vibrate. Okay. So air column is vibrated to produce a sound. So one thing is clear, that you cannot produce a sound without vibration. Right? Can you think what are the things which are vibrating inside a speaker? Is there anything which is vibrating inside a speaker? Yes, is there anything which vibrates inside the speaker?
So, like from where the sound comes, that part vibrates.
Yeah, there is a diaphragm attached to the speaker, and that diaphragm vibrates, producing a sound. Okay, so there is no sound which is produced without vibration. Even in the electronic cases, also you have attached speaker, so that also produces sound because of vibrations. So there are always some vibrations. At the home, we also have tried with the stretched rubber band. A stretched rubber band also produces vibrations, and that you have heard about humming noises that come when you stretch a rubber band or a thread and tell your friend to pluck that from any point. So you hear some sounds or humming noises are heard. Okay, so those humming noises, they are produced because of the vibration. So everyone has understood that you cannot produce a sound without any vibration, right? Understood,
Yes,
everyone?
sir. Yes, sir.
Okay. Now let's see, how does sound propagate? Propagation of the sound. How does sound travel from one place to another? And does it require any medium? So does sound require any medium to travel?
Yes, the sound requires a medium.
Can sound travel without a medium?
No, sir.
No, sir.
Are you sure?
Yes, sir.
Yes, sir.
Okay, any examples that you can give?
So, for example, in vacuum, if you ring the bell, it won't be heard.
Okay. So have you tried it out?
Yes, sir. We did this experiment in school.
Okay. Were you able to hear this?
No, sir.
Yes. So sound requires a medium to propagate. If there is vacuum, then you cannot hear that sound. So I will tell you some of the activities which you can perform at your home also to hear the sound, to see that the sound does not propagate through vacuum. It always requires a medium to travel from each other. If the sound could travel through vacuum, okay, then uh, at the sun, we have a lot of nuclear reactions being carried out. Okay, at the sun, we observe there are number of atom bombs which are regularly blasting. So you could hear those sounds from the sun. The sun is so big that you could hear those sounds from the sun and hence you will not be able to sleep on the earth. Okay. So we do not hear any sound coming from the sun. Do we hear any time any sound coming from sun? We don't hear. Okay. So that is just because the sound requires a medium to propagate. It without medium, it cannot travel. Okay. So whatever you speak here on the earth, your sound cannot escape the earth. It cannot move out of the earth. Okay. Whatever high pitched tone, whatever you talk, that means in the vacuum you cannot talk. You can't talk in vacuum. Right. So propagation of sound, understood? The sound requires a medium to travel. Now we have three types of medium. If you talk of the medium, you have three types of medium, that you have solids, liquids, and gases. So where do you think that the sound will have the maximum speed?
Solids.
Solids.
Yeah, sound has a maximum speed in solid. Sound has maximum speed in solid, and then in liquid, and then after that least in the gases. So sound has least speed in the gases. Okay. But if you talk of certain solids, there are certain solids through which sound does not propagate at higher speed. Those solids, they act as the absorbers of sound. They can absorb the sounds. Okay. So there are certain solids through which sound is absorbed. For example, wood. The sound is absorbed through the wood. Sound is absorbed through the thermocols. Sound is absorbed through the cardboard. Okay. So they are the certain certain things which help, through which the sound does not propagate much, rather uh, it is absorbed by them. So they are also used, the thermocols and wood, they are also used in theaters. Okay. For the absorption of the sound that is produced, so that the sound does not hinder the other people.
Oh yeah, they make it like curved so that the sound doesn't echo either.
That curved part we will see later on. But on the walls, you whatever bricked walls are there, on the walls, you if you observe that they have some uh, porous materials which are pasted over there. So those porous materials are present over there to absorb the sound, so that the sound does not reflect back and it does not move out of the hall. Okay. So sound is there are certain solids which can absorb the sound. Okay. So understood this? First of all, sound requires a medium to propagate. Without medium, sound cannot travel. Okay. Then it has the maximum speed in solids, then in liquids, and least speed in the gases. Now we talk something about waves. Okay. So have you heard anything about the waves? Yeah, what are waves?
Like when sound travels, it travels in the form of waves, like longitudinal wave and
Mhm. Okay, so have you seen a wave? And can we define a wave? Okay, I'll show you some of the waves. Okay, just be here. I'm showing you some of the waves which are produced. Let's see. I'm showing you some waves. Okay, so let's see. See here. As you can observe, this is a spring. Is the complete spring visible to you? Can you
Yes,
see there is something happening in both the springs?
Or the longitudinal wave is going slower. Or are they
Uh,
going at the same speed?
they are going at the same speed. But what we are observing here,
the particles are moving up and down like
And
in
down. Yeah.
okay,
just
yeah,
One that
okay,
to and fro and one that going up and down.
okay. First of all, tell me, are in both these cases, is the spring moving from its place or is it on its place only?
So in the first one, the spring is moving from its place. Second one, it's in its place.
no second one also it's moving. It's like compression and diffraction.
No, is the spring moving from its place
No, sir.
No, it's not.
in any of them, either in the first one or the second one?
No. From its place, no, but it's just moving over there.
Okay, so this is called as a slinky. If you have a slinky at your home or in the laboratory, you can ask your teacher to show it. Okay, this is just slinky, or it's also available in the market. If you compress a spring like this, suppose if you have the spring and if you compress it like this and keep it aside, so you see that here we see that something is traveling along the length of the spring, right? We observe here something is traveling along the length of the spring. So what is that is traveling along the length of the spring? Okay, so in this case we observe that you can, as you can see, there are some spaces. If you observe it closely, so at some place you will find the springs are very close, and just near this, ahead of it, you have some spring. They are away from each other. This is the normal distance between them. Can you see? This is the normal distance between the springs. And when we see these springs are very close, just ahead of it, ahead of that, just ahead of it, you have the spring which are spaced apart, right? So here, in both the cases, what is moving is a wave. That is energy. So what is wave? Some people say that wave is a disturbance. Some say that wave is a energy. So what travels through wave? Energy travels through wave. Right? Understood this?
Yes,
Through
sir.
the wave, energy is traveling. If we pressed the spring, suppose in this case I pressed the spring or I pulled the spring. So if I pressed the spring over here in the first case, so my work has turned into energy, and that energy is traveling from one place to the other, but the spring is not going anywhere. Spring is at its place. Okay, it's only the different parts of the spring, they first move like this and they come back. This is the thing that is happening. First they move like this and they come back. Observe it closely. The second one, you can see first here ahead of the compression, you can observe first the spring particles, they move like this and they again return back. Is it happening? Observe it closely. Okay, I hope you have observed this. I will show you a few more pictures so that it's still clear. Now I think you are understanding what is a wave. Okay, let's say some more things. Here, see. Okay, see, this is a slinky. Again, the same thing is happening over here. Do you observe something moving from one side to the other? Right. So that is a wave. You can observe in any. So now you have seen, and you can observe it at any place. At your home also, I think now you can see. You can observe now in your laptop or in mobile. You can see what are these waves and how they are propagating. Right. Now the second one, this was the second one. For the first one that we observed, the first one which we see the transverse wave. Now in this, the spring, what is happening over here? Some particles are moving down and some particles are moving up. Right. So it's something like this. The spring particles, they first move down, then they move up. First move down, then up. First move down, then up. So in this way they are moving. But in both of them, we observe that our energy or the wave, it is propagating along this direction, right? In both of them, the direction of wave propagation is the same. Understood, everyone? In both of them, the direction of propagation is the same, but the way the spring is vibrating. In this case, the spring is vibrating like this it is vibrating along the length. In this, we observe the spring is vibrating like this. Okay. So in the transverse wave, the vibrations are perpendicular to the direction of wave propagation, whereas in the longitudinal wave, the directions of the vibrations, they are parallel to the direction of wave propagation. Okay. So I think this is the first time. Is there anyone who had observed this earlier also? Anyone who had observed this practically? No one? Okay. So I think now you have understood about the spring. Let's see a few more, if I can say, if it can be made a little bit more clear to you. You can try the same thing with the rope also. Even if you try it with the rope, let's say you try here with a rope. Okay. So if with a rope, you just provide a pulse, you provide a small pulse, so pulse travels along the length of the rope, but the vibrations, they are perpendicular to the length of the rope. Okay. So which type of vibration is this? Which type of wave is this? Yeah, which type of wave is that? Okay. And okay, here which type of waves are produced?
Longitudinal waves.
Longitudinal waves, right? So I think now everyone has understood about the longitudinal waves and the transverse wave. So can we write down some definitions? So what are, first of all, we write down what are waves. So what are waves? How do we define wave? We define wave as, we can say it is a disturbance. It is a disturbance in a medium. So it is a disturbance in a medium, or it is the transfer of energy. So both the definitions are correct. You can say what's a wave? It is a disturbance that is created in a medium, right? Now I give you another example of the pond. Let's say the waves in a pond. Okay, I'm not talking of the ocean waves, right? So just keep that ocean waves aside. That's a different thing. We will come to that ocean waves also. But first we see waves in a pond. I think now everyone must have observed this, waves in a pond.
Yes, sir.
Okay, let's see. So waves in a pond, and we have tried something in respect to this also. See, I think all of you must have observed these concentric circles in a pond. If you drop anything in the pond, you observe such concentric circles arising, whose epicenter is at the point where you dropped the particle. Okay. So, okay, while playing cricket or anything, has it been ever, have you ever experienced that your ball has went in the pond and you try to take it out like throwing stones with it?
Yes, sir.
So did the ball come, does the ball come out like that?
Yes, so you can push the ball out with the waves.
Okay, you can push the ball. No. See what is happening over. If you observe this closely. So what happens over here? The water is not moving from its place, just like the spring was not moving. It was just vibrating at its place. So similar thing happens here also, that the water particles, they just vibrate on their place up and down. in phase. So all the water molecules which are in phase, they vibrate together. They go together down, they come together up. They are not moving anywhere. They are just transferring their energy to the neighboring particles and hence forming concentric circles. Okay. So shall I explain it once more? Here it seems to you as if the water is moving from the center to the outer surfaces. It seems to you that water from the center here, the water is moving to the outside, right? This is what you observe over here.
Yes, sir.
Okay. But the water is actually not moving outside. The water at each point, it is coming up and down, just like the spring. Okay, and all the particles which are at equal distances, they come up at the same time, go down at the same time, and in this way they form the energy transfers. So let's try to understand this once more with a diagram, because we will draw a diagram and try to understand that how it happens. See, up to now you had just studied about the longitudinal waves and the transverse waves. Okay, I'll see you had only heard about the waves. Okay, let's see how the wave is being produced. Okay, or understanding the water waves. So this I am trying to explain you the water waves. Okay, see. So see, how do we observe the water waves? We observe such concentric circles, right? So we observe such concentric circles. Suppose this is the point where we dropped a stone or something. Okay. So when we dropped the stone goes down and it pushes some amount of water. Okay. Some water goes down and again comes up. And in this way, this water transfers energy to the nearby particles. So let's have some of the nearby particles. These are some of the nearby particles which are located at equal distances from the center. Okay. So what will happen? See, all these particles which are at equal distances from the center, all of them, they get energy from this. They get energy and all of them obtain the same amount of energy at the same time. So therefore, all of them, they together go down, together come up, together go down and come up. Okay. In the similar way, you can observe. So the energy of these particles will now be transferred to the next level particles and hence they will also start vibrating up and down, right? So which type of waves are set up in water? Is it transverse wave or longitudinal wave?
Longitudinal. No, wait. Transverse.
See, how do we see the wave propagating? We observe that the wave is propagating from the center to the outside, right? Wave is propagating something like this from the center to the outside. This is the direction of propagation of wave. Okay, this is how the wave is propagated, and the particles are vibrating up and down. So can I say here that the vibrations are perpendicular? Vibrations are perpendicular.
Yes, sir.
Okay, so which type of wave is this? These are the waves in water, and such waves, they are called as transverse waves. These waves, they are the transverse waves. Okay. Now I will also put here a picture of the spring so that you are able to understand. Okay, so both the ones I'm putting, you can have the idea from both of them. This is one of them. Then you have this one where we observe in the slinky, we observe a compression and rarefaction. So I hope now you have understood how the waves are being produced. In the wave, there are two things. Some particles are there which are oscillating, and there is some movement of energy. There is some transfer of energy. Okay. So here we observe these two, we call them as, these are the waves in spring. These are the transverse waves in spring. And these ones, they are the longitudinal waves in spring. Longitudinal waves. Okay. Now let's write down some differences between longitudinal waves and the transverse waves. And then we will come to know, then we will come to sound, that whether sound is a longitudinal wave or a transverse wave. Okay. So longitudinal waves and the transverse waves. So how we differentiate the longitudinal waves from the transverse waves? Yes, Prince, what difference we observed?
Sir, in transverse, it's go up and down,
Up and down, but
and
every time we hmm,
in longitudinal, it's go straight.
okay, instead of just mold your terms a little bit, then you will get the answer. Mold your words. So in the transverse wave, we observe, what do we observe in the case of transverse waves? Here we observe that the direction of vibration, the direction of vibration of the particles, the vibration of particles is perpendicular to the direction of propagation. Okay, so understood the first point? In the transverse wave, what happens in the transverse wave? The direction of propagation is perpendicular to the direction of vibration. Both are perpendicular to each other. And in the case of longitudinal wave, okay. So what happens in the case of longitudinal wave? Just I'm making it for you so that once you get it, you can refer it anytime. Okay, it's not perpendicular, it's parallel in this case. So the direction of wave propagation is parallel. It's parallel to the direction of propagation of wave, right? Understood this? These both the waves now. Now another very important point of difference that exists between transverse wave and longitudinal waves. Okay, and that point of difference is that the transverse waves, they can propagate even through vacuum. Propagate through vacuum also. Okay. So I can say that they do not require a material medium. However, they can propagate through material medium also, but they do not require. So they do not require a material medium. They do not require a medium to propagate. So can you give examples? Now you have seen a number of examples. So I think it will be easy for you to add some of the examples. Okay. Aman, can you add any example?
Sir, water.
Water.
When you
Okay.
drop something
Waves.
in water, the waves.
Okay. Waves produced in water. Waves produced in water. The waves in water, they are transverse waves. Anything? We also observe the waves in a spring. What about the waves in a rope?
Yes, sir.
They are also the same thing. You can say waves in a rope. And a very important one, that is light. So light itself is a wave, and it is a transverse wave. It can travel through vacuum. So that is why we are able to see sun. That is why we are able to get sunlight. The sunlight which reaches us, it passes through a vacuum. Okay. So from sun to earth, there is a large vacuum space, and it is that place through which it is coming. Okay. So waves in a row, they are transverse waves in the light itself is a transverse wave. It can propagate through vacuum also. And similarly, we can write down for the longitudinal waves also, that the longitudinal waves, they do not okay. So longitudinal waves, they do not require a material medium to propagate. So they require okay. They can propagate. They cannot propagate through vacuum. Rather, they require a medium to propagate. They require a medium to propagate. And cannot propagate or cannot travel through vacuum. So just give any examples.
Sir, sound
Give me,
waves.
yeah.
Sir, sound waves, can it be an example of longitudinal waves?
Okay, sound waves. However, we have not studied. So sound. Any other?
String.
Linky.
Yeah, in the slinky, which type of waves we observed? So the compression waves. We say that compression waves in a slinky. So they are also longitudinal wave and they cannot propagate without a medium. So understood these two waves?
Yes, sir.
Okay. So can you draw a diagram? We will
Yes, sir.
draw a diagram later on. You can draw the diagram. You can draw the diagram of spring in both the cases. In the transverse wave also you can draw the spring, and in the longitudinal waves also you can draw the spring. Right? Okay. Now let's try to understand that which type of wave is sound wave and how does sound travel. Okay. So let's try to understand the sound waves. As our chapter is now towards the sound, so let us try to understand about the sound, how it is a wave, and we will also understand some of the terms like the frequency, time period, oscillations, wavelength. These are the certain things which we will understand right now. We understand, we get those topic under okay. So let's first of all study the vibrations in detail. What all things can we talk of about the vibration? Let's try to define a vibration and then we will come to the description of the wave. Okay. So all of you know about the vibrations. Just it will give you a quick revision of the vibration. Whenever you observe the vibration, as I told you that vibration is a to and fro motion. Okay. So we can consider any example to study vibration, like we can consider pendulum, we can consider a string. Okay, so let's first consider here a spring to understand a not a spring, we consider here a string. Okay, so let us have a string which is fixed at 2 points. Okay, so we have fixed this string at 2 points. Now if I move the spring, let this be the point A, let this be the point B. Okay. So now what I'm doing, see. So from the center, I pulled this spring up to this point. Let this be the point P. I pulled this up to here and then I release this. So when I release this from this point, so it will not stop over here. It will go the other way. It will go the other side. It will come over here on the other side. Right? So this is the point Q. Okay. So the spring will come here on the other side. Here you have P, here you have Q. In this way, it will keep on oscillating between these 2 points, P and Q. So P and Q, they are called as extreme points. We call them as extreme points. And the maximum distance from the mean position. So this is the mean position. From this position, let this be the point D. So PD distance, we call this as the amplitude of vibration. Okay. So have you understood what is amplitude?
Yes, sir.
Amplitude of vibration, this is the maximum displacement of the oscillating particle. You can also call QD. QD is also the amplitude. Okay. But for simplicity, we will say that PD is the positive amplitude and QD is the negative amplitude. This is the vibration in the positive direction and this is the vibration in the negative direction. Understood?
Yes, sir.
Okay. So see, this is vibration. Now, what do we call as one oscillation? Let's understand what is oscillation. Okay. So what is oscillation? Okay. It is one complete to and fro motion okay. One complete to and fro motion. Okay. Okay. So one complete to and fro motion is called vibration. Okay. So let's understand this. What we call as the one is called as oscillation, not vibration, which we called it as oscillation. Okay, see, suppose we stretched up to P and from P we release, it comes towards Q and from Q it again travels to P. Okay, so this is your complete one oscillation. Okay, this is your complete one oscillation. You can also observe one oscillation from the mean position. Suppose from the mean position it comes to Q, again comes towards P, from P again if it comes at D, so that is one oscillation. Okay, so in one oscillation it is changing its direction 2 times. Okay, don't get confused. In one oscillation the oscillating particle changes its direction 2 times. Understood the term oscillation?
Yes, sir.
Okay, let's see the time period. What is time period? What do we call the time period of oscillation? The time period of the oscillation, it is the time taken to complete one oscillation. The time taken to complete one oscillation. That is the time period. Okay, so just I'm giving you one small question and then we can end up the class. Okay, so see here, an oscillating particle completes 20 oscillations in 3 seconds. Find the time period. Can you find the time period? Very simple question. An oscillating particle completes 20 oscillations in 3 seconds. Find the time period. Yes, anyone done? Just by the definition you can compute. Chavan Kaushik, did you get the answer?
Sir, I think it's
How much?
Sir, I'm not sure, but I got 6.
Okay. See, the definition. Time period is the time taken to complete one oscillation. So you have here, take your unitary method. You have time taken for 20 oscillation. Okay. So time taken for 20 oscillation will be equal to how much? That will be equal to 3 seconds. Okay. So what will be the time taken for one oscillation? Won't it be 3 by 20?
Yes, sir.
Okay. So it will be 3 by 20, and 3 by 20, it will be 0.3 by 2, and 0.3 by 2 is 0.15 second. Okay. So bye everyone. I'll just send this to you so that you can get the definition and everything. Okay. Bye everyone. Good night.
Bye, sir.
Thank you, sir.